So see, first of all, you should know what is form factor. Form factor is denoted by KF, and that would be equal to VRMS divided by V average. Okay. What is RMS? RMS you have studied in 12th class also. RMS means root, mean, square, and average you already know. So what is the relationship of RMS and maximum? That is VRMS would be equal to Vmax divided by root 2. Like suppose we'll have the sinusoidal equation like this. Okay. So the value of maximum voltage which is goes to maximum, like suppose it goes maximum up to 220 volt. So this is known as maximum voltage, and RMS is every time we have to take the measurement of the voltage at each and every instant of time. Suppose it would be V1, V2, V3 and up to Vn. So Vrms would be equal to root of V1 ka square plus V2 ka square plus V3 ka square up to so on Vn ka square divided by n. Why? Because it is known as root. That's why I have taken root mean square. Okay, mean and square. Understood? This is known as root mean square. Now tell me, like if I'll say you that at our home we are getting 220 volt supply. So 220 volt according to you is the RMS value or the maximum value? Hmm? Hello? Yeah. This 220 volt which we are use in our home, that is the VRMS value. Okay. So now form factor is, as I told you, VRMS divided by V average, and formula for RMS is Vmax divided by root 2. Average formula is 2 Vmax divided by pi. If we'll solve it further, Vmax would be cancelled out. A final answer would be pi by 2 root 2. That would be 1.11. So always remember that form factor value is always equal to 1. Okay. Similarly, we'll have peak factor Kp, that is Vrms sorry, that is Vmax divided by Vrms. Vmax is equal to Vrms is Vmax divided by root 2. Again it would be cancelled out. Root 2 is 1.414. Correct? Okay. Now back to our question. Whenever you will get this kind of waveform, so we have to use different formulas regarding that. What was the formula? For I average, I average is limit. It varies from alpha 1 to alpha 2. I of dt divided by the base length. Similarly, we'll have the formula for IRMS is equal to root of limit vary from alpha 1 to alpha 2 I square dt divided by the base length. Now for this we should know what is alpha 1 and alpha 2, right? As you can see, it's in the symmetry. So if the waveform is in the symmetry, so we'll consider only the half cycle. Okay, only the positive cycle. So according to this is alpha 1, this is alpha 2, as it vary from 0 to 1. So can I write down alpha 1 is 0, alpha 2 is 1. Okay. Now next about the base length. As you can see that it vary from 1 to 0. So base length would be equal to 1 minus 0. Got it? And now we need to calculate I, right? How can we calculate I? As you know, this is then angle theta, right? So tan theta is how much according to you? Tan theta is perpendicular over base. Perpendicular is how much here? The current I. Base is how much? Time. I is how much here? 5. Time we don't know. Time is, yeah, 1. 0 to 1. So can I write down, if I'll solve it further, can I write down I would be equal to 5 of t? Hmm? So now we got all the values. We just substitute the value. It vary from 0 to 1. It vary from 0 to 1. I is how much? 5t dt. Base length we have calculated that it vary from 1 to 0. So base length is 1, right? Minus 0. So can we solve it further? If we'll integrate it, then it would be 5t square by 2, 0 to 1, right? So that would be 5 into 1 ka square by 2. So the answer would be 2.5 ampere. Clear? Now similarly, if we'll do it for this one, then root limit vary from 0 to 1. I square means 5t ka square dt divided by 1 minus 0. Now we can solve it further, then we'll get 5 by root 3 ampere. Now if they ask you to calculate form factor, as you know the form factor value is RMS by average. We already calculated IRMS and I average. You can divide it. And further division you will get the same value, that is 1.11. Okay. Again similarly you can calculate the peak factor. Understood this thing?